In this video, we're going to talk about ecosystem structure. We'll focus mostly on ecosystem, which is the interaction between the biotic and abiotic factors, as well as biome, which is a larger area that has similar climate, precipitation, temperature, and all that. And there are certain characteristics of each biome. The big questions that we want to answer are how are ecosystems structured and how do ecosystems function? We'll first start with climate, and then we'll talk about the different types of biome. You don't have to know the specifics of what are the different types of biomes, what are its characteristics, but you want to have an idea of what determines the characteristics of a biome. And then we'll talk about the certain laws that all ecosystems obey, such as the law of conservation, which is also the first law of thermodynamics, limiting factors, energy transfer, and nutrient cycles. So we'll start with seasonality. The season is formed because the Earth is not uniform. The Earth is not a perfect sphere, but it's kind of a spherical shape. There are different seasons because the Earth rotates around this axis, and the Earth also rotates around the Sun. And at different time of the year, the Sun overheads at different part of the Earth, which allows a certain area of the Earth to be hotter than other areas at different seasons. During March equinox and September equinox, the sunlight is directly overhead of the equator. During December solstice, the sun is overhead at the Tropic of Capricorn. And on June solstice, the sun is overhead at the Tropic of Cancer over here. So this allows the northern hemisphere to have summer during our regular summer, and the southern hemisphere have summer in December. And this is fall and spring for the northern hemisphere. This is all caused by the rotation of Earth around the sun and the rotation of Earth itself. So during summer, we have the most direct sunlight. If you have a northern hemisphere summer, that's when the most direct sunlight is in the north. And during winter is when you have the least direct sunlight. So during our northern hemisphere summer, the southern hemisphere is experiencing winter. Global circulation is also caused by the uneven heating of Earth's surface, depending on which part of the Earth is receiving the most sunlight. So at the equator, you always have a lot of sunlight. So that's where there's a lot of heat. So as you can see in this picture, at the equator, for example, there's a lot of moist and hot air. So if you have a hot air, you know that it automatically goes upward over here. And then it travels this way because this is where the colder air is, and then the air comes down back to the Earth. As the air descends over here, this also leaves a drier area because all of the moist air is over here. But as the air is traveling through this way, you'll have a drier air in this area. So as you can see, air circulates like this around this area. But over here is the opposite because air is coming down this way, so air also has to come down this way. And then ascends this way, causes a circulation around this area, and another circulation around this area. The southern hemisphere is kind of the opposite of that. So you can see how air is going upward at this point, this point, and this point. This is the global air circulation kind of from the Earth to, so this is a global circulation between the Earth's surface and the atmosphere. But this also causes how wind is formed on the Earth's surface. You can also have air going from the Tropic of Cancer to the equator. And this air tilts to the left in the northern hemisphere. And this is caused by the rotation of the Earth itself. And same thing over here, because we have air going this way, we have all the air going from here to here, and it tilts toward the left. Here we have the opposite. So this uneven heating of Earth is what causes all of these air circulation, which in turn causes the difference in climate conditions around the Earth. Because of the uneven heating of the Earth, there's also an uneven heating of the ocean. So we have area of the ocean with warmer water near the equator, and we have colder water near the two poles. And this allows the circulation of water. The direction is different between the northern hemisphere and the southern hemisphere. The water current is also kind of similar to the wind circulation. So as you can see, in the northern hemisphere, the water circulates clockwise, and in the northern hemisphere, the wind also circulates clockwise. This is a surface feature. If you have a mountain, the front of the mountain where the air hits is usually wetter than the other side of the mountain. This also affects a local climate, which is a smaller area where the climate is different. The next one that we'll talk about is a biome. We'll first start with a terrestrial biome, and then we'll talk about the aquatic biome. There are a lot of factors that determines the characteristic of a biome. For example, sunlight, which also kind of affects precipitation and temperature, as well as soil quality. All of these will determine the amount of biodiversity around a certain area and characteristic of that area. In this graph, you can see the annual mean precipitation and the annual mean temperature that's different between different biomes. This picture also shows you, in general, where a certain biome is located at different parts of the Earth. You might be familiar with some of these biomes, such as desert and savanna, but you might not know exactly what the differences are between the different forests. The important thing for us to understand is what causes the different types of biomes and its characteristics. So here's some major biomes and examples of the biomes. The first one is Denali National Park in Alaska. This is an example of boreal forest biome where there's a very cold and long winter, a short summer, and a very large temperature range throughout the year. There's very good biodiversity around this area. Because of the biodiversity, the soil is also really rich. The second one, a forest in Norway, is an example of a conifer forest. A conifer forest usually has a long, dry winter. Precipitation kind of varies depending on what part of the continent it's at, but in general, there's a pretty good amount of precipitation. And because these areas are close to the North Pole, the ground is often frozen, which kind of restrict the amount of biodiversity. There are a lot of these Christmas tree-shaped trees around this area. This is actually the largest terrestrial biome around the Earth. This next one is a desert, so the desert itself is a biome. As you know, the desert is usually really dry and really hot. The next one is the Great Smoky Mountains National Park in North Carolina. This is an example of temperate deciduous forest. The temperature and precipitation is usually mild, and you can see the 4 distinct seasons throughout the year. There's usually a warm summer, a cold winter. The trees are less dense than a rainforest. This next one is an example of a temperate grassland. This next one is a tropical rainforest. You might know that tropical rainforest is usually very humid and there's a lot of biodiversity. Next one is an area of chaparral in California. Chaparral itself is a type of biome. It's kind of similar to a desert, but it usually has more rainfall than a desert. And as you can see, there's more trees and more biodiversity than a desert. The next one is a savanna. A savanna is usually located between forest and a desert, and there's a lot of grass. What's not shown is a polar ice and high mountain. You can kind of imagine how those two areas is going to look like.